calculus of probabilities. That is what I shall call objective probability, and it is this phenomenon which has to be explained. There are numerous insurance societies which apply the rules of the calculus of probabilities, and they distribute to their shareholders dividends, the objective reality of which cannot be contested. In order to explain them we must do more than invoke our ignorance and the necessity of action. Thus, absolute skepticism is not admissible. We may distrust, but we cannot condemn en bloc. Discussion is necessary. 1. Classification of the problems of probability. In order to classify the problems which are presented to us with reference to probabilities, we must look at them from different points of view, and first of all from that of generality. I said above that probability is the ratio of the number of favourable to the number of possible cases. What for want of a better term I call generality will increase with the number of possible cases. This number may be finite, as, for instance, if we take a throw of the dice in which the number of possible cases is 36. That is the first degree of generality. But if we ask, for instance, what is the probability that a point within a circle is within the inscribed square, there are as many possible cases as there are points in the circle, that is to say, an infinite number. This is the second degree of generality. Generality can be pushed farther still. We may ask the probability that a function will satisfy a given condition. There are then as many possible cases as one can imagine different functions. This is the third degree of generality, which we reach, for instance, when we try to find the most probable law after a finite number of observations. Yet we may place ourselves at a quite different point of view. If we were not ignorant, there would be no probability. There could only be certainty. But our ignorance cannot be absolute, for then there would be no longer any probability at all. Thus the problems of probability may be classed according to the greater or lesser depth of this ignorance. In mathematics we may set ourselves problems in probability. What is the probability that the fifth decimal of a logarithm taken at random from a table is a 9? There is no hesitation in answering that this probability is 1/10. Here we possess all the data of the problem. We can calculate our logarithm without having recourse to the table, but we need not give ourselves the trouble. This is the first degree of ignorance. In the physical sciences our ignorance is already greater. The state of a system at a given moment depends on two things, its initial state and the law according to which that state varies. If we know both this law and this initial state, we have a simple mathematical problem to solve, and we fall back upon our first degree of ignorance. Then it often happens that we know the law and do not know the initial state. It may be asked, for instance, what is the present distribution of the minor planets? We know that from all time they have obeyed the laws of Kepler, but we do not know what was their initial distribution. In the kinetic theory of gases, we assume that the gaseous molecules follow rectilinear paths and obey the laws of impact and elastic bodies. Yet as we know nothing of their initial velocities, we know nothing of their present velocities. The calculation of probabilities alone enables us to predict the mean phenomena which will result from a combination of these velocities. This is the second degree of ignorance. Finally, it is possible that not only the initial conditions but the laws themselves are unknown. We then reach the third degree of ignorance, and in general we can no longer affirm anything at all as to the probability of a phenomenon. It often happens that instead of trying to discover an event by means of a more or less imperfect knowledge of the law, the events may be known and we want to find the law, or that, instead of deducing effects from causes, we wish to deduce the causes from the effects. Now, these problems are classed as probability of causes, and are the most interesting of all from their scientific applications. I play at écarté with a gentleman whom I know to be perfectly honest. What is the chance that he turns up the king? It is 1/8. This is a problem of the probability of effects. I play with a gentleman whom I do not know. He has dealt 10 times, and he has turned the king up 6 times. What is the chance that he is a sharper? This is a problem in the probability of causes. It may be said that it is the essential problem of the experimental method. I have observed n values of x and the corresponding values of y. I have found that the ratio of the latter to the former is practically constant. There is the event. What is the cause? Is it probable that there is a general law according to which y would be proportional to x, and that small divergences are due to errors of observation? This is the type of question that we are ever asking, and which we unconsciously solve whenever we are engaged in scientific work. I am now going to pass in review these different categories of problems by discussing in succession what I have called subjective and objective probability. 2. Probability in mathematics. The impossibility of squaring the circle was shown in 1885, but before that date all geometers considered this impossibility as so probable that the Académie des Sciences rejected without examination the, alas, too numerous memoirs on this subject that a few unhappy madmen sent in every year. Was the Academy wrong? Evidently not, and it knew perfectly well that by acting in this manner it did not run the least risk of stifling a discovery of moment. The Academy could not have proved that it was right, but it knew quite well that its instinct did not deceive it. If you had asked the academicians, they would have answered, "We have compared the probability that an unknown scientist should have found out what has been vainly sought for so long, with the probability that there is one madman the more on the earth, and the latter has appeared to us the greater." These are very good reasons, but there is nothing mathematical about them. They are purely psychological. If you had pressed them further, they would have added, "Why do you expect a particular value of a transcendental function to be an algebraical number? If r be the root of an algebraical equation, why do you expect this root to be a period of the function sin 2x, and why is it not the same with the other roots of the same equation?" To sum up, they would have invoked the principle of sufficient reason in its vaguest form. Yet what information could they draw from it? At most, a rule of conduct for the employment of their time, which could be more usefully spent at their ordinary work than in reading a lucubration that inspired in them a legitimate distrust. But what I called above objective probability has nothing in common with this first problem. It is otherwise with the second. Let us consider the first 10,000 logarithms that we find in a table. Among these 10,000 logarithms I take one at random. What is the probability that its third decimal is an even number? You will say without any hesitation that the probability is 1/2. And in fact, if you pick out in a table the third decimals in these 10,000 numbers, you will find nearly as many even digits as odd. Or, if you prefer it, let us write 10,000 numbers corresponding to our 10,000 logarithms, writing down for each of these numbers +1 if the third decimal of the corresponding logarithm is even, and -1 if odd, and then let us take the mean of these 10,000 numbers. I do not hesitate to say that the mean of these 10,000 units is probably 0, and if I were to calculate it practically, I would verify that it is extremely small. But this verification is needless. I might have rigorously proved that this mean is smaller than 0.003. To prove this result, I should have had to make a rather long calculation for which there is no room here, and for which I may refer the reader to an article that I published in the Revue Générale des Sciences, April 15, 1899.